Welcome back to Spark tutorial by Learning Journal. In the previous session, we learned about the application driver and the executors. We know that Apache Spark breaks our application into many smaller tasks and assign them to executors. So, Spark executes the application in parallel. But do you understand the internal mechanics? How does the Spark breaks our code into a set of tasks and run it in parallel? That's the topic for this video. We'll try to deep dive inside the Spark and look into internal mechanics of parallel processing. The objective of this video is to develop a solid understanding of Spark's execution model and architecture. So, fasten your seatbelt and let's start for the ride. All that you are going to do in Apache Spark is to read some data from a source and load it into Spark, process the data and hold the intermediate results, and finally write the results back to the destination. But in this process, you need a data structure to hold the data in Spark, right? We have three alternatives to hold data in Spark: data frame, data set, and RDDs. We'll learn about all of these. In fact, Spark 2.x recommends to use the first two and avoid using RDDs. So, the primary focus of this training will be on these two items. But there is a critical fact to note about RDDs. Data frames and data sets, both of them are ultimately compiled down to an RDD. So, under the hood, everything in Spark is an RDD. And for that reason, I will start with RDDs and try to explain the mechanics of parallel processing. Great, let's define the RDD. The name stands for Resilient Distributed Dataset. However, I can describe it like this. Spark RDD is a resilient, partitioned, distributed, and immutable collection of data. Let's quickly review this description. Collection of data. This one is the most basic thing. They hold data and appears to be a Scala collection. Resilient. That means they can recover from a failure. RDDs are fault tolerant. Partitioned. Spark breaks the RDD into smaller chunks of data. These pieces are called partitions. And instead of keeping these partitions on a single machine, Spark spreads them across the cluster. So, they are distributed collection of data. Immutable. Once defined, you cannot change them. So, Spark RDD is a read-only data structure. You can create an RDD using two methods: load some data from a source or create an RDD by transforming another RDD. Let me show you an example. We'll load some data from a file to create an RDD, and then I'll show you the partitions. Let me create a file. Good. I can load this file into an RDD. When you create an RDD by loading some data from a source, Spark creates some default partitions. Let's see what do we have. If you want, you can override the defaults and create as many partitions as you want. The second parameter in this API is the number of partitions. Let's verify it. If you want, you can iterate to all partitions and count the number of elements for each partition. Let's do that as well. Great. Now we know that an RDD is a partitioned collection, and we can control the number of partitions. However, that wasn't the objective of this video. At the beginning of this video, I said that I'm going to explain this. How does the Spark breaks our code into a set of tasks and run it in parallel? Let me ask you a simple question. Given this RDD, if I want to count the number of lines in this RDD, can we do it in parallel? No brainer, right? We already have 5 partitions. I'll give one partition to each executor and ask them to count the lines in the given partition. Then I'll take the counts back from these executors and sum it. Simple, isn't it? That's what the Spark does. Let's execute the code to count the number of lines in this RDD. Good. Now let's check the Spark UI. I'll show you what happens under the hood. Here we are. What do you see? One job, one stage, and 5 tasks. Let's try to understand these 3 things. We asked for the count, and hence Spark started one job. A job to calculate the count. Spark breaks this job into 5 tasks because we had 5 partitions. One counting task per partition. A task is the smallest unit of work and it is performed by an executor. We are running in local mode and I have a single executor. Hence, all of these tasks are executed by the same executor. You can drill down to this report and check the details. We had 5 tasks and the driver itself executed all of them. You can try the same thing on a real multi-node cluster and see the difference. Great! I think by now you have a fair idea about the parallel processing in Apache Spark. There are 2 main variables to control the degree of parallelism in Apache Spark: the number of partitions and the number of executors. If you have 10 partitions, you can achieve 10 parallel processes at the most. However, if you have just 2 executors, all those 10 partitions will be queued to those 2 executors. There is one more point that is worth mentioning at this moment. Look at this line of code a bit carefully. What do you see? It is the data, I mean a collection, plus a function to execute on that data. The data is already partitioned and distributed over the executors. Now all that the Apache Spark has to do is to send this function to those executors. They run the function on the partition that they have and return the result. That's it. That's how Apache Spark breaks our code and get it executed in parallel. This approach emphasizes the importance of the functional programming. All of this is so simple because we package our logic in functions and Spark can easily pass these functions from one place to another place. While learning Apache Spark, you will realize that everything that you do in Spark is either calling a function or creating a function. Great. So far so good. Let's do something little more complicated and take our understanding to the next level. Here is an example in Scala as well as in Python. Let me quickly explain the code. Line 1 loads a text file into an RDD. The file is quite small. If you keep it in HDFS, it may have 1 or 2 blocks in HDFS. So, it is likely that you get 1 or 2 partitions by default. However, we want to make 5 partitions of this data file. The line 2 executes a map method on the first RDD and returns a new RDD. We already know that RDDs are immutable, so we cannot modify the first RDD. Instead, we take the first RDD, perform a map operation and create a new RDD. The map operation splits each line into an array of words. Hence, the new RDD is a collection of arrays, right? The third line executes another map method over the array RDD. This time, we generate a tuple, a key value pair, right? I am taking the second element of the array as my key and the value is a hard-coded numeric 1. What am I trying to do? Well, I am trying to count the number of files in each different directory. That's why I am taking this directory name as a key and 1 as a value. The new KV RDD should look like this. Once I have this RDD, I can easily count the number of files. All I have to do is to group all the values by the key and sum up these ones, right? That's what the fourth line is doing. Reduce by key. That means group by key and sum these ones. Finally, I collect all the data back from the executors to the driver. That's it. I'm assuming that you already know the mechanics of map and reduce methods. I've covered all these fundamentals in my Scala tutorial. I've also included a lot of content about functional programming. If you are not familiar with those fundamentals, I strongly recommend that you first go through my Scala training to take full advantage of the Spark tutorials. Great! I hope you don't have any doubts about the example code here. Let's execute it and see what's happening behind the scenes. This time, I want to use a multi-node cluster. So, here is my 6-node Spark cluster. Let me create the data file on my master node. Let's copy it to HDFS. I just want to make sure that we execute this example on a data file that resides on a real distributed storage. Let's start the Spark shell. Paste the first 4 lines in the shell. Great! We executed 4 lines of Spark code. Now, I want to go and check the Spark UI for this application. Here it is. Strange. I don't see any jobs here. Only executors are there, right? I executed 4 RDD operations and in fact created 4 different RDDs. But I don't see any Spark jobs. There is a reason for that. All these functions that we executed on various RDDs are lazy. They don't perform anything until you run a function that is not lazy. We call the lazy functions as transformations. The non-lazy functions are actions. Let me formalize these 2 terms. RDD offers 2 types of operations: transformations and actions. The transformation operation creates a new distributed dataset from an existing distributed dataset. So, they create a new RDD from an existing RDD. The actions are mainly performed to send results back to the driver, and hence they produce a non-distributed dataset. The map and the reduce by key are transformations, whereas collect is an action. All transformations in Spark are lazy. That means they don't compute results until an action requires them to provide results. That's why we don't see any jobs in our Spark UI. We'll come back to transformations and actions in the next video. For now, let's execute an action on this final RDD and check the Spark UI once again. Great! Now we see 1 job, 2 stages and 10 tasks. Apache Spark has completed this job in 2 stages. It couldn't do it in a single stage, and we will look at the reason in a minute. But for now, just realize that the Spark has completed this job in 2 stages. We had 5 partitions, so I expected 5 tasks. Since the job went into 2 stages, we have 10 tasks. 5 tasks for each stage. Let's drill down further. You can see that there are 5 tasks per stage. That's what I said, right? Let's click on the DAG. The Spark DAG shows the whole process in a nice visualization. This one is the file load. This one is the first map operation. This one is the second map operation. Spark was able to complete all of these 3 activities in a single stage. But for the reduce by key function, it took a new stage. The question is why? Let's make a logical diagram to understand this. Here is my initial RDD. I created 5 partitions and Spark assigned these partitions to 5 executors, right? Now, I need to execute my first map operation. Read each line and split it into individual words, right? I can quickly order this transformation to my executors. They'll perform this function on the partition that they hold. After completing the first transformation, they keep the transformed data with themselves. They don't need to send it to me because I haven't asked for it yet. I again ordered them another map operation. Create a key value pair for each row. They complete that work and keep the new transformed data with them. So far so good. There is no need to send the data from one executor to other executor or to the driver. There is no need for any data movement yet. And hence, Spark was able to perform all of this in a single stage. But what do we want to do next? We want to group the whole dataset by the key and then count the number of ones for each key. However, the keys are spread across the partitions. How is the Spark going to do that? Well, to accomplish this task, we need to repartition the data in a way that we get all the records for a single key in one partition. This new partitioning is based on the key. So essentially, these old partitions will send data to the new partitions. The exchange of data happens in a way that it collects all the data for the same key into a single partition. We don't have to write code for all this exchange. Spark framework performs all of these actions behind the scene. We call it a shuffle and sort activity. During this exercise, Spark moves the data and creates new partitions. That's why it needs a new stage. So, whenever there is a need to move data across the executors, we need a new stage. Spark Engine will identify such needs and break the job into two stages. While learning Apache Spark, whenever you do something that needs moving data, for example, a group by operation or a join operation, you will notice a new stage. I'll show you a few more examples as we progress through this training. Once we have these key-based partitions, it is simple for each executor to calculate the count for the keys that they own. Finally, they send these results to the driver because we executed the collect method. Great! We learned a lot in this session. By now, you must have a fair idea about the following things. RDDs are the core of Spark. They represent a partitioned and distributed dataset. We can perform transformations and actions over the RDDs. An action on an RDD triggers a job. Spark breaks the job into stages. A shuffle activity is a reason to break the job into two stages. Each stage is executed as a set of parallel tasks. The number of parallel tasks is directly dependent on the number of partitions. However, apart from the tasks, the degree of parallelism is also limited by the number of available executors. I also talked about how the notion of functional programming makes more sense for Apache Spark. In the next video, we'll cover some other interesting concepts. Thank you very much for watching Learning Journal. Keep learning and keep growing.